Alrighty, hi fifth graders. We are today learning about numerical patterns and coordinate planes. This is something that we have been working on for the last week and a half or so, but today we're really going to dive into numerical patterns. Oops, sorry about this. There we go. So last week, we focused on graphing ordered pairs and identifying coordinates. So given an ordered pair, you were asked to create the coordinate point on a coordinate plane. And today and the rest of this week, we are going to be focused on these standards. So by the end of this week, your goal is to be able to generate two numerical patterns using given rules and identifying relationships between corresponding terms. Also, you'll be able to form ordered pairs consisting of your corresponding terms from the two patterns and graph the ordered pairs on a coordinate plane. So to begin today, we want to do a think, pair, share. And instead, because we're at home, I am going to do a think aloud. So talking through what I would think about when I see this problem. So it says the following table shows how many songs Ella downloads each week. How many songs will she download in week 5? Okay, so when I look at this table, I see that there's a column for week and I see there's a column for songs. So when I look at the week column, I see that it goes 1, 2, 3, 4. And I see that it increases by 1 each time. Okay, so I can identify that the pattern for weeks is that it's increasing by 1. For the songs, I see that it starts with 4 songs, and at week 2, it jumps up to 9 songs. So the difference between 4 and 9 is adding 5. Well, from week 2 to week 3, it goes from 9 to 14. The difference between 9 and 14 is also 5. Let's see if it works for the last one. Between 3 and the 4th week, it goes from 14 to 19. So that's also a difference of 5. If I did 14 plus 5, I would get 19. So for songs, I can say that each week, Ella increases or downloads 5 songs each week. So if I'm looking and going back to my question, how many songs will she download in week 5? Well, if it increases by 1 week, then I need to also add 5 more songs. So 19 plus 5, that would equal 24. So Ella will download 24 songs in 5 weeks. So the numbers in this table are called terms. When you hear the word term in today's mini lesson, you'll want to think about these specific numbers. Any number in these tables is called a term. The terms create a sequence. So the weeks, 1, 2, 3, 4, 5, create a sequence. The songs are also a sequence. So all the terms made up equals a sequence. Let's look at this numerical pattern. So the question is, what is the rule for this sequence of terms? Remember that a sequence is the list of numbers and the terms are the individual numbers. So one strategy that you can use when identifying a pattern is to figure out the difference between the numbers. Now, it won't always be simple, like adding 1 or adding 5. Sometimes it might be multiplication or division or addition or subtraction, or sometimes it could be a combination. But the biggest thing that you can start with, and the most important one, is to find the difference. If you identify that the difference is the same between each numbers, then you know it will be an adding or subtracting pattern. So if I start with 3 and I jump to 7, I just can see that the difference is 4. And if I go from 7 to 11, then I also see that that difference is 4. I want to make sure that this works with all of my terms. So take a minute. 11 to 15, 15 to 19, do those also have adding 4? Yes, they do. The rule is add 4. Because each time I go from one term to the next, I'm adding 4 more. So I can conclude that the rule for this numerical pattern or for this sequence is add 4. Okay, how about this one? What is the sequence for this, or sorry, what is the rule for this sequence of terms? So I start with 101, and I jump to 121. Like we did on the other one, we want to start with trying to find the difference. So 101, jump to 121, I know is a difference of 20. Well, I can see it goes from 121 to 141, another difference of 20. Does it work for the rest of the sequence? Yes, it does. Add 20 is the rule for this sequence because as we go from one term to the next, we're adding 20 each time. Okay, another one. Remember that not all numerical patterns will have a rule of adding or subtracting. So I see here 1 to 4, there's a difference of 3. 4 to 16, well, that's definitely not 3. So I know that from 4 to 16 is 12. So I go from plus 3 to plus 12. 16 to 64. Wow, that's a big jump. Okay, so I know that this is not going to be adding because the differences between these are not the same. What about multiplication? What times 1 equals 4? Well, 4 times 1 equals 4. Does that work for the next term? 4 times 4 equals 16. Does it work for the next term? 16 times 4 equals 64. I think we found our rule. Does 64 times 4 equal 256? It sure does. The rule is to multiply by 4. So each time that we multiply the term by 4, we get the following term to create this sequence. All right, let's do one last one before we move on. All right, here it is. What is the rule for the sequence of terms? So we go from 2 to 4. Okay, so that's adding 2. 4 to 5. That's adding 1. 5 to 10. Yeah, that's adding 5. I know something's going on that's not just an add or subtract or even a multiply the same number here. Because, can you figure it out? I see that 2 times 2 equals 4. So maybe it's 2 times multiplied by 2. 2 times 4? No, that can't be. So this one is tricky because what it does is, like I said earlier, sometimes it's a combination of multiple operations. So the first term to the second term is times 2, but then it does a plus 1. So the rule is multiply by 2 and then add 1. That's the entire rule. Look how it works out for the rest of the sequence. 5 times 2 is 10. 10 plus 1 is 11. 11 times 2 is 22. 22 plus 1 is 23. Kind of cool, huh? Patterns are fun to find. Now, sometimes it can be frustrating because maybe we don't see it right away. But remember that these numerical patterns always have a pattern. You just kind of have to dig deep sometimes. Okay, now if you have any questions about how to find patterns, you need to make sure that you are asking me this week and at any point during your assignments. So let's put this into practice. So how can we use our knowledge of numerical patterns to graph ordered pairs? Well, you know, because of this past week's work and last week, that when we plot a point on a grid, we want to plot the x-axis first, and that's that first number. And when we plot the x-axis is the bottom axis here. It's the one that lays flat. You go horizontally. Remember when we use our arms to resemble the axis, that the x is flatter. When the y, we stand nice and tall. So when we plot the y-axis, we do that second. and we go up. We go vertically up towards the point that we need to plot. Okay, so let's fill in this table using the rule add 3. So look at this. It says pattern 1. We start at 0. It's really important, 5th graders, to look at your starting point. So 0 plus 3 is what I need to do to find this pattern and to fill in this table. Okay, so that's 3. Then I need to add another 3. Well, what's 3 plus 3? 6. What's 6 plus 3? 9. Okay, now we're going to fill in the second pattern. See here that we're filling in a table. You could probably guess what we're going to do. Yep, eventually we're going to graph this table. So pattern 2 is a multiply by 2. So I need to take my starting number here and multiply it by 2. Okay, so 1 times 2 is 2. What's 2 times 2? 4. What's 4 times 2? 8. So now I've completed my table. Pattern 1 was add 3. Pattern 2 was multiply by 2. Now we're going to write the ordered pairs from the corresponding terms. So we just made pattern 1 and 2. Now we're going to write the ordered pairs. So if the pattern 1, remember it's on the left-hand side, and that's our first number. So that's going to be our x coordinate. Pattern 2 is that second number, that y coordinate. And so when we make this, we can label the x and the y coordinates. You can see in the green and purple writing. Now I'm going to also label, just as a reminder, that it goes x comma y for my ordered pairs. Okay, so the first one is 0 comma 1. What's the second one? 3 comma 2, 6 comma 4, and our last one is 9 comma 8. Okay, so now we're to the point where we're going to graph this. Now remember that we started with an empty table and we used the rules that they were given, like add 3 or multiply by 2, to create these ordered pairs. Because after we had a table, we were able to take the x coordinates and the y coordinates and create the ordered pair. So first we're going to graph 0, 1. 0 starts at the origin. Remember, the origin is 0, 0. So when I have 0, 1 as my ordered pair, I go over 0. That means I stay at this origin point. And then I'm going to go up 1. And I'm going to put my point there. The next one is 3, 2. So I'm going to go over 3 first. So notice that the dot jumped over to 3 on the x-axis. And it's going to go up 2. That is shown by this coordinate, 3 comma 2. Okay, how many are we going to go over on 6 comma 4? Well, since 6 is in the x-axis, we go over 6 and up 4. Last one. So it's 9 comma 8. Because the 9 is first, we walk across the x-axis to 9, and then we jump up to 8. And there we go. We have completed our graph based on our table. So remember, 5th graders, that this week you are going to be working on those numerical patterns, and that you need to be able to find and write and graph those ordered pairs that you create from your sequences and from the terms that you are provided by identifying the pattern that the table has. So with that, go ahead and begin this week's assignments. Thank you for listening, and remember that I am here for you whenever you need, and especially during this math.